This video is titled Rational Numbers, Multi-Step Real-World Problem Solving. Recalling a few common formulas in mathematical processes can help us decipher and make sense of real-world problems. Let's review a few key points. A formula that's pretty common is distance equals rate times time. Formulas for area and surface area of regular shapes might help us with problems with wrapping paper or something of that order. Being able to convert between units of measure, a lot of times these word problems will have different units of measure and might have some seconds, minutes, and hours, and we have to determine how to convert those so they're all the same so it's easier to do the math. And of course, most importantly, using the order of operations. Let's look at the first problem. Nate walked the entire 7.4-mile nature trail in 1.5 hours. Carson did the same trail at an average pace of 5.9 miles per hour. Did Nate have a faster or slower average pace than Carson? How long did it take Carson to walk the nature trail? Well, the information that we can gather from the problem itself, we know the total distance for both of them, for Nate and Carson, is 7.4 miles. We also know that Carson's rate, or his pace, is 5.9 miles per hour. And Nate's time, although we don't know how fast he was running or walking, was 1.5 hours. If we look at the two questions, did Nate have a faster or slower pace than Carson? Once we find out what Nate's actual pace was, then we can also determine how long it took Carson to walk the nature trail. We would have all the information we need and we'd be able to do that comparison. We'd be able to find out who went faster based on how long it took. So based on the information given in the problem, using the distance equals rate times time formula will help us solve it. So first we'll look at Nate. 7.4 miles is the distance, and we don't know what his rate was or how fast he was going, but we know that it took him 1.5 hours. So if we divide the distance by the time it took him, we can figure out how fast he was going or what his pace was. So 7.4 miles divided by 1.5 hours, we get 4.93 miles per hour. We can answer part of the problem now. Was Nate's average pace faster or slower than Carson's? Well, remember, we already know Carson's pace because that's in the problem. So Nate's was slower, 4.93 miles per hour. Now, based on a slower rate, you would say then that it probably took him longer. Since we know that Nate's average pace, his rate, was slower than Carson's, we can expect that it would take less time for Carson to walk the trail. So now we're going to solve that part of the problem. Carson, 7.4 miles, same distance. At 5.9 miles per hour, we don't know his time, how long it took him. But if we divide the distance by his pace, then we will get the time it took him. 7.4 miles divided by the 5.9 miles per hour, it took him 1 hour and 15 minutes, or 1.25 hours. And as expected, 1.25 hours is less than 1.5 hours. Let's look at another problem. Mrs. Carson wants to hang a framed photograph of her beloved puppy Smooch directly in the middle of the wall. The framed photo measures 18 inches by 18 inches. Now you notice the dimensions of the wall. From left to right, 10.5 feet, and from ceiling to floor, 7.5 feet. And we know that the photo measures 18 inches by 18 inches. So based on those dimensions, How many inches away from the walls on either side, left to right, and from the ceiling and the floor from top to bottom, should she position the picture? We're going to have an equal distance from, say, the ceiling to the picture and from the floor to the picture, and the same distance from the left side of the picture and then from the right side going to the picture. Since the picture dimensions are in inches and the problem asks for a solution in inches, we'll convert the other measurements given in the problem to inches. So 10.5 feet equals 10.5 times 12, because there are 12 inches in 1 foot, and that gives us 126 inches. And then from ceiling to floor was 7.5 feet, so that's 7.5 times 12, because again there's 12 inches in every foot, and that'll give us 90 inches. To figure out how many inches we should measure in on either side of the photograph from left to right, we're going to subtract the length, 18 inches of the photograph, from the total number of inches that the wall measures from left to right. So from left to right we have 126 inches, minus the 18 inches, which is the length of the frame photograph, and we end up with 108 inches. Well, now we're going to divide what's left, that 108 inches, by 2 in order to determine the distance we need to measure from each side of the wall. 108 inches divided by 2, that means we're going to measure 54 inches from the left side and 54 inches in from the right side. Now remember, we want this frame photograph to be absolutely centered. So now to figure out how many inches we should measure from the ceiling down and up from the floor, we're going to subtract the height of the photograph, which happens to also be 18 inches, from the total measurement of the height from floor to ceiling, which was 90 inches. So 90 inches minus 18 inches is 72 inches. And then just like before, we're going to divide by 2 so that we have an equal distance between the ceiling and the photograph and the floor in the photograph. So 72 inches divided by 2 is 36 inches from the ceiling down and 36 inches from the floor up. Let's do one more. Mr. Corbin invested $300 in the stock market 2 years ago. The first year, the value of his stock went down 2.1%. And this past year, it went up 4.6%. There has been no change since then. What is the value of his stock now? Well, just from an estimation standpoint, I can look at this and say, if it went down 2.1% and then it went up 4.6%, I could subtract those two percentages and say basically it went up 2.5%. But there is just going to be a little glitch that is going to keep that from being perfectly accurate. So the first thing we're going to do is convert the percentages to their decimal form. It's going to be easier to do the multiplication and the math. Remember that a percent is a number over 100. When we divide by 100, we move the decimal point to the left 2 places because there's 2 zeros in 100. 4.6% therefore is then going to equal 0.046%. Why? Well, let's look at where the decimal point is. I'm going to move it back 2 spaces. There's 1. I'm going to have to put a 0 placeholder, and there's 2. That's where that decimal point goes. And 2.1% is going to be 0.021. So remember, Mr. Corbin invested $300. The first year, the value of his stock went down 2.1%. So we're going to take our $300 and we're going to multiply it times that number, 0.021, and we get $6.30. Well, if the stock went down, we're going to need to subtract that amount. So 300 minus $6.30 gives us a new value after that first year of $293.70. $293.70 is the value of the stock after 1 year. So now this past year, the value of his stock went up 4.6%. So we take the current value, which happens to be $293.70, we multiply it times our percentage, we get $13.51. Since the stock went up by that amount, we're going to add $13.51 to our current value. And that gives us $307.21 is the current value of his stock as of right now, since there has been no change. Okay, well that ends this little video on multi-step word problems. Enjoy the activity.